What I could have done is simply listed a whole load of complex pathways in pulmonary hypertension. Paul showed you a nice simplified diagram of the 3 major pathways that we target. There are so many. Now, what I thought I would do is not do that and go through the principles of pulmonary hypertension and some of the areas that we're tackling. In particular, some of the areas that we are tackling in the UK. We are world leaders in novel research studies in the UK, partly down to the fact that we are extremely well organised as a national network. But just as an example, I'm putting up here from the PVRI, which is the Pulmonary Vascular Research Institute, of which Paul is currently president. They have an annual congress. As you can see, the one last year is the 3rd one, so it's a relatively new organisation, which is about delivering new drugs for pulmonary hypertension in collaboration with the pharmaceutical industry. Often what we do is repurpose drugs that are designed for other diseases, and we use them in our own. So metformin, for example, has been around for decades for diabetes. So this is just a list of some of them that were discussed last year. So there are tens, if not hundreds, of therapies currently up in the air for treatment of pulmonary hypertension. Now, only very few of those will get through the final selection process, and I will show you a little bit of that later. So rather than actually just list them all and bore you to tears, I thought I would try a little bit more of a structured approach. Now, so Paul very helpfully has gone through the process and the underlying pathophysiology of pulmonary hypertension. So I don't have to do this, fortunately. We start off, however, with the fundamental problem, which is the blood vessels remodeling. This puts pressure on the heart. This can then lead to a more systemic problem. So the whole body is affected by pulmonary hypertension, particularly noticeable with, for example, impaired muscle function. Many of you will notice perhaps that your leg muscles aren't as strong as they used to be. And then this can lead in the end to all the things we know about pulmonary hypertension and its impact on life expectancy, exercise capacity, quality of life, and even psychological symptoms and feelings of well-being and mood. Now, starting with the pulmonary vascular problem. Paul has given this nice introduction, so it makes my life very easy. This is a nice normal blood vessel in the lung, and you can see that blood is flowing through it relatively easily. I don't have the nice video that he has. On the bottom left, we've got some of these factors that Paul has showed in his 3-pathway model of pulmonary hypertension. These are factors which cause blood vessels to dilate and some which cause them to constrict. And there is this imbalance. So when we look at what happens in pulmonary hypertension, we have this imbalance with the constrictors being overactive and the dilators being underactive. This constriction process is absolutely core to pulmonary hypertension, and it's the drugs that we have against these constrictors which are currently the ones in use and that many of you will be taking. So the first thing that we really do when we look at developing new drugs for pulmonary hypertension is say, what can we do? What can we find to dilate these arteries? Now, part of the problem, of course, is that drugs are never 100% selective to the lungs. So you could give huge doses of sildenafil, and apart from some of the side effects that it might have, one of the problems you would have is that you end up dropping your blood pressure because it's not just acting on the lungs, it's acting on all the other arteries. So that's one of the problems we have. So I wanted to introduce something that Neil mentioned, which is denervation, which is something that's in development. Sheffield have done a lot of the animal work, and currently ourselves at Hammersmith with Sheffield are leading a study, a worldwide study on pulmonary artery denervation. Now, what is denervation? Well, if you consider this tree, it's got ivy growing up around it from the ground, and those are like the nerves that are wrapping around the main pulmonary artery, and they go all the way out to the edge. And imagine that the nerves are like the ivy, but they're releasing factors into the branches that are causing the branches to constrict. So that's one of the latest theories in the development of pulmonary hypertension. And clearly this is very focused to the pulmonary circulation. So one thing you can do, if you were doing this on a tree, is just to cut at the base of the tree, and the ivy would die off all the way around the tree. This is going to be very selective to the nerves around the pulmonary artery, and it's not going to affect the nerves elsewhere. This is what pulmonary artery denervation is. It's effectively killing off the nerves through heat heating up just to about 45 to 50 degrees Celsius, killing off the nerves which are very sensitive to heat, such that they then die off and don't release these constrictive factors. This is the Chinese technique of using an ablation catheter. You can see the top left, there's a sort of a long catheter that you can put in at the same time as a right heart catheter, and it has this circle of 10 heating elements, which when you put into the pulmonary artery, and you can see on the next slide here, it's probably hard to orient yourself, but the one that's coming in from the bottom is the catheter. You can see it wrapping around. That's in the left pulmonary artery. You heat it up, and that causes the nerve endings to die. And this is the theory behind it. But it is still very much in trial. We've done 2 cases. Sheffield have done 4 cases. And there have been 10 cases, I think, done across Europe now. So it's still in development. Now, constriction itself can lead to this remodeling process, the thickening process, but it can also, remodeling can, we think, can happen of its own accord. Now, what we are not good at the moment is having drugs that specifically target remodeling. There are so many out there that are currently in potential use, and Neil mentioned one which sadly didn't make it through, which is imatinib. Many of you may have been on the IMPRESS trial. But one of the areas that we're currently targeting in the UK, and this is where a study that Papworth is leading on in collaboration with Roche, which is a pharmaceutical company, is an anti-inflammatory molecule. So we have all these factors that cause the blood vessels to thicken, but some of them are released by white cells, these inflammatory cells that circulate around the bloodstream, but also lodge in the pulmonary arteries. So one of these is called interleukin-6. Now, I don't want to go too overboard with the science, but basically interleukin-6 is a molecule that circulates around and can potentially cause remodeling. The way it does this, and I think it's useful to explain this, is that the interleukin-6 is the round circle there. It then attaches itself to the green bar, which is a receptor that circulates around with it. And when they attach, they form a key. That key then gets inserted into the lock, which is effectively around the cell membrane. So the smooth muscle cells that Paul was mentioning, that lock is in that membrane. When you put the key in the lock and you turn it, the door opens, or a set of commands get sent down the chain, and that leads to the smooth muscle cell increasing in size and increasing in number. By giving this drug, which I can't really pronounce, tocilizumab, I think is the best way of saying it, this drug can effectively mop up these molecules in the circulation and effectively stop the key from forming so it doesn't get into the lock. This drug is given as a solution because it's an antibody, and it's an antibody that needs to be given once a month. And some of you may be in the study. It's a pan-UK study, and we've recruited a couple of patients, and I think every centre is involved. So some of you may be on this. So this is a once-a-month treatment, and it's ongoing, and I'm very excited about it. Then one of the final things in the pathway is that blood vessels can begin to clot as a result of the slow blood flow through the system, and many of you will be on drugs like warfarin or potentially some of the newer direct oral anticoagulants like rivaroxaban or apixaban to prevent blood clots. But there is this condition called chronic thromboembolic pulmonary hypertension. Some of you raised your hands, you have this. There is a new treatment that's potentially coming out in the UK for this. We are behind the rest of the world on this because we are struggling to convince the NHS of its worth at the moment, but Papworth are leading the way on this, and Joanna Pepkizaba is doing her very best to push this through as fast as possible. What this is, you've heard of endarterectomy surgery. This is balloon pulmonary angioplasty. Angioplasty has been around for years in the coronary circulation. You basically put a small balloon into the pulmonary artery, or in the case of coronary disease, into the coronary artery. You inflate the balloon, and very simplistically, you shove everything out of the way. Now, here's an example you can see on the left of a blood vessel in the lung that's been blocked by blood clot and scar. On the right, you can see the result. You can still see the wire going down into the pulmonary artery after the balloon inflation, and you can see a very satisfactory result with increased blood flow. Clearly, that's going to decrease the pressure. So this, we hope, is on its way soon to the UK and should be potentially suitable for patients who are not suitable for surgery. This is not an option. This is not an alternative to surgery. This is for people who are not suitable for surgery. So if you've been turned down for surgery and you're on drug therapy, this may become an option, and we will have to reevaluate all of your cases. Now, ideally, what you want to do is you want to get to the root of the problem. And many people say, what's the cause of idiopathic PAH? Well, we know that in some cases, in heritable disease, there is a single gene defect that has gone wrong, and this accounts for many of the cases of heritable pulmonary arterial hypertension. So understanding how this works may unlock the key to many, many other therapies. So the mutation is called a BMPR2 gene, and without wishing to get too complex here, I want to use my key analogy. Here we've got an imbalance, and effectively what you've got is two doors into your cell. Through one door, the good guys can go in, that's the BMPR2 pathway, and through the other door, the bad guys can get in, that's the TGF-beta pathway on here. If you have a defect in your BMPR2 pathway, and that can either be because the key doesn't fit, there's no lock, or the door doesn't open, whatever it is, there are lots of different ways it can go wrong. You can't get as many good guys into the room, and so the bad guys win. Okay, so what we have is an imbalance in the signaling pathways in the cell. So one of the things to do is that if there is a defect in that pathway in a small number of patients, and this is where we'll have to be selective, we're looking at ways of trying to put that right in terms of restoring the function of that receptor, in other words, getting the lock working again. But in other cases, what we can do is effectively try and put more people outside the room, more good guys outside the room that can get through the door, even if it's a small door and not working very well. Those are the BMPs. So there are ways that potentially we're looking at tackling this by understanding the root causes. And that's why the cohort study that many of you will have enrolled in, which is looking at how blood changes in pulmonary hypertension, is giving us many clues on how to take this forward. And we are genuinely leading the way. We may not win the World Cup, but we are certainly providing a lot of food for thought to the international community in terms of treatments for PAH. Now, impaired heart function and impaired muscle function I kind of lumped together, mainly because, I'll admit, we struggle to find therapies that can directly improve heart function. The way we are going to tackle pulmonary hypertension, and dare I say cure it, that may be many, many years down the line, is by targeting the problem in the lungs. But yes, it would be nice to help support the heart a little bit more while we're still struggling to find that final cure. Now, one thing I did think I would put up is exercise, because this is the European recommendations. You can see in the middle, supervised exercise training should be considered in physically deconditioned PAH patients, which I'm sorry to say is probably most of you, because it's hard to exercise when you've got pulmonary hypertension. It's hard to keep your muscles strong, who are undergoing medical therapy. Now, why is that? Well, this top graph here summarizes some of the studies in pulmonary hypertension. It's a complicated thing to understand. It's called a forest plot. But the bottom line here is that what it shows in the biggish black diamond at the bottom is that on average, people who go into exercise studies improve their 6-minute walking distance by about 72 meters, which is pretty much double the effect of any drug. These people are all on drugs as well. In other words, exercise, which is cheaper to deliver than many of the drug therapies, can do more for your 6-minute walk test. That's why Paul mentioned it. That's why it's so important. And we're lagging behind in the UK in getting this done. And I'll explain why in a second. One of the reasons why. The Germans, however, are fantastic at this, particularly in Heidelberg. And you can imagine a lovely rehab hospital in the hills in southern Germany, and a lovely environment in which to undergo a 3-week period of inpatient rehab. They've done a randomized trial. Eckhart Grunig really is the protagonist behind all of this. Now, what they've shown is, yes, improvements in 6-minute walk when you randomize people to training versus no training. And in terms of quality of life, in the green bars, across all these domains like physical functioning and general health and mental health, emotional roles, all of these things tend to improve with exercise training. So this is training mind and body. And looking in detail at what it's actually doing, and I'm going to just focus on this one graph down here. Green, remember, is the training group, and I will, trust me on this, an increase of 1 litre per minute per kilogram in terms of cardiac index is huge. So these patients' hearts are pumping much more strongly at peak exercise, which is why they can do more. We don't really understand why that is. Is it an effect on the lungs? Is it an effect on the heart? Clearly the muscles are stronger. But I'd like to think it's having some benefit on the heart. We know from heart failure that sometimes exercise is the only thing that can really help. So this is one of the problems we have. What you've got on this rather complicated graph is on the x-axis, the bottom going along, is distance to the closest centre, and on the y-axis is the number of patients referred to PH centres per million population. What you see is that if you live near a PH centre, you're more likely to be referred to one. But the point I'm making here is that many patients are living 200 kilometres away from their nearest PH centre. Try going to an exercise rehab class to somewhere that's 200 kilometres away. It's very hard. So in Glasgow, they're doing this in-house study. They've got the perfect hospital for that because half the hospital is a hotel and the other half is a hospital, right? So we are looking to them to provide evidence on a UK level to see if this works. What about muscle function? So this is one of my favourite topics, iron. We're currently undertaking a randomized placebo-controlled study. The gold standard of studies to really find out if this is going to help. And a lot of people I know are asking about iron. We really don't know yet if this is good for you or bad for you. This is a study where everybody got iron. So in other words, there could be a lot of bias. The 6-minute walk test didn't improve. This was done in Amsterdam. We sort of were slightly involved in it at Hammersmith. And what they found was that exercise endurance increased. But don't forget, everybody knew they were getting iron. So there is the impact of the placebo effect on this. However, they also had muscle biopsies. I'm not going to take you through this, mainly because I don't really understand it myself. But the muscle biopsies showed that the muscles in patients who were given iron were able to use oxygen more effectively. So in other words, iron perhaps is working on the muscle, possibly not working on the heart or on the lungs, but we wait to find out. So there are lots of these different areas that we can potentially tackle. Now, how does a drug get to market? Could we have a show of hands? How many here have taken part in a clinical trial with a drug therapy? Wow, that's great. Could you all stand up, please? And as a show of gratitude to these people who've helped develop drugs that the rest of you are taking, I think we should give them a round of applause. So, there are probably many of you in here who said, but yes, I would have liked to have been in a trial and I would have volunteered. Part of the problem is trials are very restrictive in who they take on. But the reason, and I think that's quite an impressive number, the reason that we can do that is because we have large volume centres which are fully resourced to do clinical studies, not itty-bitty little centres here or there who don't have the machinery to do studies. That's really important. This is the life cycle of a drug, okay? So you go from phase 0, where you give very small doses to healthy people potentially, and small doses to patients. You're really looking at safety as you go around to phase 2. You're using right heart catheters to find out if the drug works on the pulmonary circulation. Phase 3, in terms of efficacy, you're looking to see what impact does that drug now have on relevant things like 6-minute walk. And most of the drugs that you're on were licensed using 6-minute walk. But more recently, the 6-minute walk trials were done over 12 to 16 weeks, but more recently we've had to take on much longer, more burdensome studies with hundreds and hundreds of patients lasting up to 2 to 3 years looking at the impact of drugs on meaningful events. So what are these events? This is a rather detailed slide here, but this is showing you the trial design that was used in a study that licensed macitentan. And here, these are the things that counted as an important event. So patients were divided into placebo, or macitentan in this case, and if one of these things happened, then an endpoint was reached. And you had to basically wait until enough events had happened before you could close the study. So if you look at what happened, this study really went out for 3 years, but at 2 years, at 24 months, you've still got about 500 patients in the study. So these are big studies, and you can see that many patients aren't even having an event. So even if you're on the placebo arm, 60% of patients aren't having an event. So they're going into the study and nothing's happening. That's why these studies need to be massive and they need to be long. And that is part of the problem that we have. And one of the things that you are potentially going to have to face as a trial volunteer is going into a study for long periods of time. In a 6-minute walk one, you got an answer by 16 weeks because you got a measurement. Everyone got a measurement. So just to explain where these future therapies are coming from, and this is really a plea. We can do these because we're large volume centres and we are resourced to do research. I'm aware, of course, that we have shared care partners out there. We manage patients in collaboration with shared care. But if you never get to a PH centre, you will never get this opportunity, which is not great for you, and it's not great for UKPH, and it's not great for global PH. So I think one of the concerns I have is when these drugs start to get cheaper, and bosentan will come off patent, so it will get cheaper. We've already got cheaper sildenafil. One thing we need to guard against, you need to guard against, and the PHA needs to guard against, is basically the dissolution of the pulmonary hypertension network, because we will no longer be able to do research. We won't be able to collect your blood, we won't be able to put you in trials, and so we must protect against this. The PHA was incredibly successful in preventing NICE from destroying and taking away all your drugs. You just need to keep on your toes. Thank you. Now, the last part of my talk is really about technology. Now, it has arrived, and whether you like it or not, in 10 years' time, you are going to be using technology a lot more to communicate with us. We've got things like the doctor will see you now over your phone, and we're developing apps such as MyPAH to try and integrate into patient management. So here's an example of a patient, fictional patient, okay, it's a real ECG, a 42-year-old woman with idiopathic PAH, normally functional class 2, in other words, breathless on moderate exertion, climbing stairs, that sort of thing. She comes for her 3-monthly review, but she tells you 2 weeks ago she became more breathless, dizzy, and had palpitations. What's happened? Well, Paul alluded to the fact that it's important to be in sinus rhythm. She has developed an arrhythmia. She's gone into atrial flutter. We can put that right again, but clearly it's not good for somebody to be in that for a prolonged period of time, and there's no use just waiting for 3 months. Now, you can ring up Wendy, who's sitting in the back there, and you can say, I don't feel so good, and she'll probably sort you out, but it may be better to have a slightly more robust approach. How could this have been prevented? So you can do direct ECG monitoring. There's the AliveCore app. You can stick this on the back of your phone. You can put your fingers on it, and it gives you a rhythm strip, and you can send it to somebody. So it could have been picked up that way. Alternatively, if you'd been monitoring your heart rate, your weight, your saturations, and your blood pressure, you'd have seen this. Your heart rate would have shot up. Hang on a minute, this ain't right. So if we can start to monitor you at home, we're not going to be spying on you. You're in control of your data. You can send it to us when you want. Then maybe this will lead to a change in how we manage you. So there are, of course, lots of things that you can monitor. You can monitor heart rate, weight, SATs, blood pressure, exercise. How many people have got a Fitbit or something along those lines in here? Yep, smattering of hands. So one of the things we know is that, this is a slightly scary slide, I'm not quite sure how to interpret it, but what it means is that if you're moving for more than 15 hours a day, it doesn't mean you have to be walking for 15 hours a day, you have a better survival than somebody who is just not able to move. Now, so measuring your activity could tell us how you are. So what we see in this graph here, let's just focus on the left with the sort of the solid bars, control patients and IPAH patients. The number of daily steps is reduced in IPAH patients, not surprisingly, and the mean energy expenditure is also reduced. And the amount of steps you take seems to correlate. So in other words, there's a relationship. The more steps you take in a day relates to your 6-minute walk. So we can monitor your 6-minute walk for you on the basis of how many steps you do on a daily basis. Why might that be of interest? Well, here is an example of 3 separate patients with heart failure, not pulmonary hypertension, who had an activity monitor stuck into their defibrillator. The top patient is doing rather well. The activity goes up, stays up. The middle patient goes up a little bit, and then you see it drop down, and then you see a vertical line when the patient was hospitalized. But 3 weeks before that, the exercise started to drop. So we can predict when you're getting worse. And sadly, the patient on the bottom really never made it off the runway in terms of exercise capacity. They're clearly a very powerful predictor of how well you're doing. What about putting in PA pressure monitors? So Paul talked about the right heart cath. Not many of you like it. What about if we could put a microchip in your pulmonary artery? Here I have to declare an interest. I've been a paid consultant for a company that's making these microchips. We could measure your pulmonary artery pressure on a daily basis when you're walking by simply putting a reader over here. So bye-bye goes the right heart cath, potentially, not always, but also we could put you on a therapy. If it doesn't work, we can stop it, put you on another one. This is possibly science fiction, but this is already in use in heart failure. And it decreases hospital admissions and death because people can see what's about to happen. Will it work in pulmonary hypertension? Well, it's different from heart failure. We always say to you, what's my pressure on my echo? Ignore that, because that's not really important. It's the function of the heart. So we are a long way off, and we need to do some work on this, but we will be. We can do other things through technology. We can deliver mindfulness training, so in terms of psychological support. What else can we do? We can deliver decision aids. We can help you to make decisions about, should I be assessed for transplant? Maybe should I be assessed for prostacyclin therapy? And what else can we do? Perhaps we can even deliver rehab at home. And if you live 200 kilometers from a PH center, perhaps that's what we need to be doing. So I'm just going to finish up with perhaps a little bit of a plug. This is an app that I've been developing with GSK. Again, I'm going to declare an interest here. I have been a paid consultant for this app. And I should also say I've been a paid consultant for Actelion, who market macitentan, which I've mentioned. I think it's important this is going out on video that I declare my interest. So this app, My PAH, it's called, is still in development, and we've been doing a lot of work with Janelle on this. There are a number of things it can do, okay? The idea is that you can use it on your own, or you can share your data with us, and you can have a portal up to which you can upload your data. And by sharing a PIN with us, we can then look at your data. And what I would like us to do is to get this app out there and to start using it in a constructive way in a group of patients and evaluate it in outpatients. So you come in and we get your app up on screen and we look at it and we say, how have you been? You're rating your mood, your exercise, you can put your diet in there, you can put your compliance of drug therapies in there, should you wish. Paul's done some great work on compliance, showing that the more compliant you are, the better your 6-minute walk. So these tools are very useful. You can integrate it with your Fitbit or with your Withings device or with your Jawbone. That's not literally your Jawbone. For those who don't know, it's a device like a Fitbit. So you can integrate it with these things. You can even measure your quality of life on it. We can do this on a day-to-day basis, a weekly basis, and this is what Janelle has been doing, is validating this app so that it does the same thing as the paper version. And you can share that with us. You can go back and you can look at your trends over time if you wish. And finally, when you come to clinic, you can show us your data. So this is something that I think, if we look 10 years down the line, we will be doing this, so we need to get ahead of the game. If we think we're going to create the perfect tool, then we've got to be kidding ourselves, because sometimes the best is the enemy of the good, and you've just got to get on and do what you can. Thank you very much. I think you'll find that was 28 minutes.
Was it 28 minutes? Excellent.
Yeah.
Okay, just a few excellent, really good. One thing I will say, and we'll talk about this again, and is this issue, and it's not to put fear into people, really it's a rally call, this issue of protecting that we've achieved, my colleagues here, over the last 20 years with PH, that there is a danger that there is disinvestment. There's some evidence of that happening in healthcare per se. It cannot and must not happen in PH. You lot here are too valuable for that to happen. I want you to, from today, one of the things that you will get by the end of today is a realisation that together we are stronger. We've been doing some work with some organisations, the Town Seeking Trust, for example, of seeking their advice that, 20 years ago they were in a very similar position as us. The disease was different. There was news this week that with HIV, you will live as long as your contemporaries now. That's where we want to be, but it will not happen if there's disinvestment here. There is much excitement in PH. You've heard it, it's palpable, it's there. But there is a danger at the moment due to misunderstanding and a desire not to care. There's a danger that some of our society is losing its moral compass about the things that really matter. But it's really important that people like you and ourselves work together. So that's one thing. There's a promise there, Luke. If you continue working hard, we'll support that. Okay?
I'm here. It's Saturday morning.
Okay.
Yeah.
Excellent. Excellent. So many thanks for that. What we I was going to ask one question. If you had, because we've got 2 minutes, if you could have anything that you wanted in PH, anything, I'm your fairy godmother. Look at me, I'm your fairy godmother. All right? You can have it. What would you want today in PH? In either care, management, you can't have a cure, but what's the one thing? Unfair question, but you can answer it.
I think if you want me to give a realistic answer, I would like to have the free reign of all the licensed therapies available and to be able to practice best evidence-based medicine. And I think in the UK we are still restricted. Now, we are a lot better than many, many other countries around the world. But I think we are still slightly limited in some of the drugs that we can access. And I would want to practice that, I think, in a system whereby we are effectively fully funded to use all the resources that we have in terms of research, in terms of assessing patients at the time we want to see them, so that we can integrate perfectly best modern practice into research. So that's a bit of a waffly answer. I basically want it all, but I want a system that works so that we can drive this forward. So we've got, for example, this system we're setting up with a UK national collaborative network of centres. I want it such that when a new potential therapy comes along, we do not have to go through piles and piles and piles of paperwork to get a trial in place. I want us to have a framework into which we can slot new therapies. And I would like, I think I've found my answer, I would like almost everybody to be in a clinical trial. There you are.